All hydrocarbons, whether crude oil or products, are flammable. The reason for the existence of an inert gas system is to prevent fire and explosions. In other words, safety. Safety for all those sailing and working on the ship. To be certain that this safety is sustained, proper procedures are essential all the time. This training package is intended to amplify and emphasize your own training and the material in your ship's inert gas or IG manual. Complete knowledge of this is vital to all deck officers on tankers. The importance of the IG system is reflected in the way its operation is established in international conventions. The idea behind inerting the tanks is to make fire or explosion impossible because the oxygen level in the tank atmosphere is too low. If we compare the percentage oxygen in the air with the percentage of hydrocarbon gas, fire is only possible under limited conditions. Outside these, there is either too little oxygen or too much or too little hydrocarbon gas for ignition. So the percentage of oxygen is crucial to give a good safety margin. The maximum permissible percentage of O2 in inert gas is set in SOLAS at 8% or less for older ships and 5% for new ships. Some terminals require levels of 5%. The inert gas pressure must always be positive to ensure that air does not penetrate the tanks and increase the oxygen level. The generation of inert gas starts with either the exhaust flue gas or gas from an inert gas generator. This gas has been used for combustion and its oxygen content has been reduced to 5% or below. The gas goes via the uptake valve to the scrubber with its seawater cooling inlet and outlet. Inside the scrubber, the hot gas is sprayed with water. It is cooled and most of the soot and sulfur dioxide are removed. The gas passes through a demister to remove as much of the water as possible. There are blower inlet valves before the main IG supply fans. To ensure correct pressure, there is an automatic pressure regulating control valve. Finally, there is either a funnel vent to atmosphere or a recirculation valve and line. These are used to vent or recirculate gas after starting until oxygen content and gas flow is steady. Most important are the fixed oxygen analyzer and pressure recorders. A number of alarms will be fitted. To the scrubber to show low water pressure and high water level, to the supply fans to show if they malfunction, after the fans to show if inert gas temperature is too high, and to the oxygen analyzer and recorder to show if the oxygen content rises above the required minimum. Finally, to show if there is power failure to the oxygen analyzer and gas pressure regulator. A well-run system will provide inert gas with oxygen below 5% that is cool and is free of solids and the worst corrosive gases. Once the gas has been generated and cleaned, it needs a delivery system. And that's what we're going to look at next. After the pressure control valve comes the deck water seal. This prevents gas from the tanks, which will usually contain hydrocarbon vapors, from entering the engine room spaces. Then there is a mechanical non-return valve and a deck isolating valve before the gas enters the deck main. There is pipework to deliver the gas to the tanks. On the deck main, there is a pressure vacuum breaker to ensure that excess pressure or vacuum will not damage the tanks. Finally, there are 1 or 2 mast risers for venting to the atmosphere. Generally, each tank will be fitted with a tank isolating valve. Each isolation valve must be fitted with a locking arrangement. Each tank will have either a full flow individual pressure vacuum relief valve or a breather valve, or an electronic pressure sensor. This is to fulfill SOLAS requirements for full flow vapor relief or pressure sensors to provide secondary protection against over or under pressurization. Immediately after the non-return valve is a pressure sensor and recorder with a high pressure alarm. A further alarm is fitted which activates if the power supply to the pressure sensor fails. Wet type deck seals will be fitted with a low water alarm. That then is the entire system. Now we shall examine how it should be started up before examining its use during different cargo operations. First, the delivery side. It is important to give plenty of notice to the engine room.
Hello engine room, tube officer here. If you could start the IG system please.
They may have to create sufficient load on the boiler to ensure that the boiler will deliver flue gas that will have a low enough oxygen level. If there is an inert gas generator, this will have to be started. Good communication between the deck and engine departments is needed to ensure that soot is not generated during IG operations. The deck department must not rapidly change the boiler load, and the engine department should not soot blow. Both departments need to go through their checklists before the system can be used. The oxygen analyzer must be checked and calibrated. The recirculation and vent valves need to be checked to ensure that they are fully functional. The scrubber needs particular attention. Water must be started early to the scrubber to ensure that the internal surfaces are wet. The water flow should be checked before the flue gas can be connected to the system. When the gas enters the system, it will at first be operated with either the recirculation line or funnel dump line open. While this is happening, a tour of inspection should be made, checking the scrubber for hotspots and ensuring again that inlet and outlet water are flowing correctly and the alarms are operational. The IG fans need sufficient lubrication. They must be checked to see that they are running coolly and smoothly without excess noise or vibration, and that there is no water in the casing. Their alarms and trips also need to be checked. The deck seal needs to be checked to ensure that it is fully operational and that the water level is correct. The deck seal pumps are in operation continually, except when all the tanks are gas-free. The IG main PV breaker must be kept in perfect working order in accordance with the manufacturer's instructions. In cold weather, glycol may have to be added to the water. So the water may need to be checked for level and density. Like the deck seal, it is operational all the time, not just when the system is running. Following the correct sequence is important both in starting up and in closing down the system. Follow to the letter the correct procedures in the ship's inert gas manual. Note that at the end of operation, the scrubber water should be run for at least 1 hour to ensure that all the corrosive residues are washed out of it. Maintenance of this part of the system is extremely important, as the internal environment is very corrosive. Maintenance of the IG system is a crucial part of maintaining the ship's operational capability. This will usually be done on the ballast passage. The lines should be pressured and checked for leaks. The deck water seal, the non-return valve and all PV valves need to be checked regularly to ensure that corrosion has not affected their operation. The ship's planned maintenance program will tell you how often this needs to be done. Make sure you do it thoroughly. Now that we've looked at the inert gas system itself, let's examine in detail how it's used during the ship's different cargo operations, starting with loading. During loading, the inert gas system is normally not required. The mast riser valve, if fitted, needs to be in the open position. If the terminal prohibits release of vapor to the atmosphere, all vapors must be returned ashore using a vapor return line. After loading, it is vital to remember to return the mast riser valve and all vent valves to the normal closed position. During the loaded passage, the pressure must be maintained within the designated pressure range. Early in the loaded passage, vapor release can make it too high. The tank PV valves are designed to deal with this by allowing venting to atmosphere. Movement of the cargo in heavy weather can have the same effect. In some conditions, venting during the day as the temperature rises may mean topping up with inert gas at night when the temperature falls. The IG pressure must be monitored throughout the voyage to ensure it does not become too low. It is during the discharge that the inert gas system is most important. Its correct operation is vital to the entire procedure. Before the discharge begins, the system must be run up and checked. At first, the system is operated either with venting or on recirculation. It must not be run for long on recirculation, as the temperature and oxygen content of the gas may increase. Before gas is delivered to the tanks, the system must be allowed to stabilize and the pressure set in the cargo control room.
Air Control, that's 1, 2 and 3 manifold fully open now.
I have a cargo handling plan for you.
Yes, the captain gave me...
There will always be a lull while the safety checklist and cargo matters are sorted out. Once these have been agreed, and there is positive IG pressure, the discharge can begin.
That's 1348, commence discharge. Cargo deck watch, if you can have a check round on deck please, and check the offshore manifold.
As the ullage is small at the start, the correct pressure will be reached quickly. Then there will be a period of adjustment as the inert gas supply adjusts to the rate of discharge and the increasing tank space above the cargo. The deck crew needs to monitor the IG system throughout the discharge. If the system fails, cargo discharge will have to be stopped. If the IG pressure falls, then cargo pumps will need to be slowed. If the oxygen level becomes too high, alarms will sound, and the system may vent to the funnel or shut down automatically. Cargo operations will not be able to start again until the inert gas is operating properly. Once the discharge is complete, inert gas is delivered to the tanks until the designated pressure is reached. The oxygen content of the tank atmosphere must be 8% or below, and the pressure at least 100 millimeters water gauge. Once these conditions are achieved, the plant can be shut down.
Hello engine room, tube officer here. That's just finished with the IG. If you could switch it over to diesel and shut it down.
Okay.
The inert gas system is generally not required during the ballast passage, unless there is a need for further purging prior to gas freeing to permit tank entry. The first step in tank entry is purging the tank until the hydrocarbon level is below 2% by volume. Once this value has stabilized, then gas freeing can begin. It must continue until the oxygen content is 21%, and a combustible gas meter shows a reading of less than 1% of the lower flammable limit. Hydrogen sulfide may also need to be checked. Check the Materials Safety Data Sheet, the MSDS, to see if you need to check for benzene or mercaptans. This gas freeing can either be by the dilution or displacement method. Your ship's manuals will tell you which your system is designed for. In gas freeing by the dilution or mixing method, air is forced in through specially designed nozzles. Analysis of the oxygen content must be made at several different levels to follow the progress of the procedure. The air must enter at high velocity to ensure thorough mixing. The probes show the gradual replacement of the gas. In the displacement method, low velocity air is required. Again, several readings are needed. Here, there is a boundary between the inert gas and the air. The probes will show a sudden change rather than a gradual one. Any tank entry must be approved by the master and supervised and strictly controlled by a senior officer and the correct procedures observed. These procedures will be found in the ship's manuals and in the International Safety Guide for Oil Tankers and Terminals, Appendix I. Once all personnel have left the tank and all equipment has been removed, the tank will need to be re-inerted. Re-inerting will be by the same method as gas freeing, either the dilution or displacement method, whichever is used on your ship. Oxygen readings should be made regularly, at least at the top and the bottom of the tank, until the oxygen content is below 8%. There are no hidden secrets in successfully operating an inert gas system. It takes attention to detail, keeping to the proper procedures, and keeping up with maintenance. The inert gas system is a fundamental safety system of every petroleum tanker. Inert gas is protecting the ship throughout each and every operation, both at sea and in port. The correct operation of all components of the system is especially important during discharge, when it is vital to the commercial success of the ship, as well as to the safety of everyone on board. During operation, the deck department must continually monitor the inert gas oxygen content and pressure. During ballast voyages, make sure that the system is given the proper attention and that the maintenance schedule is kept.
Pumps are now settled at 1200 revs there, Gary, if you want to come up while we do the line displacement.
Be certain that you understand and keep to the procedures set out in your manuals. Make sure that you keep the system correctly maintained. The inert gas system is one of the most important safety installations on any tanker. Take good care of it, and it'll take good care of you.